Hello, Keith Rucker here at VintageMachinery.org. Well guys, I've been promising it for a while, and I'm finally got my drill presses, my Carlton, this is a 4-foot, 9-inch column, radial drill. It's ready, restored and ready to go. And at the same time, I have my other drill press, my 21-inch Cincinnati Bickford drill press, also restored and ready to go. So what I'm going to do in this video, I think, is kind of show you a little bit about both of these machines, go through, show you the features of them, and let's put them to work and actually give them a little bit of a drilling to do, see how they perform. So we'll start out with the Carlton Radial Drill. Why is it called a radial drill? So unlike a typical drill press, this one here you see is on this arm, and the term radial comes from radius. And with this one you can basically pull this arm up here, and then the whole head swings around, radially swings around that radius. So you can move the head around wherever you want to go, and then when you get it where you want, you just lock it back in place. So the other adjustments that you have, with this drill press, so let me just say this, with a big drill press like this, one of the advantages it has is that you can work on very large pieces, very heavy pieces. With a typical drill press, when you're drilling, you put your part up underneath there and you move the part around to wherever the drill is. With the radial drill, you do the exact opposite. You actually move the drill to where you want to put the hole. And you do that by adjusting the 3 axes. Number one, the radial action there that will do the left and right. We can move the arm in and out, or the head in and out on the arm. So I'll pull my lock down here. There's a hand wheel, and the whole head moves in and out. You can put that wherever you want to, and then whenever you get it positioned, lock it back in place. The third adjustment you may need is the height, to get the height on there where you want it to be. For that, because this thing is so heavy, rather than cranking on it, it's actually got motor assist. So we push this arm up, it engages a motor, which then raises the whole head up. When you get it to where you want, you just pull this lever back into the neutral position. It stops to come down. Same thing, pull the handle down. Motor engages and it raises and lowers that head to where you want it. So that gives you where you can move this around and actually put your hole right where you want to. Very easy to do. Let's zoom in here now and we'll show you some of the other controls on this. So in addition to being able to move the head around where you want, there's lots of other levers and handles on here to control different things. So first and foremost, to control the spindle itself, to turn the drill on, we got a handle right here. You push it this way, it turns the drill chuck in a clockwise direction, which is the direction you would drill. Go back to neutral, it stops. If you go the other way, it reverses that drill. That'd be counterclockwise. So that would be for coming out of a hole or something like that, or if you were tapping, power tapping, to pull back out. Now it has a quill in it, just like a regular drill press. And to go up and down, you got these 2 handles here. These are called the cow horns because of their shape. They're kind of shaped like the horn on an old longhorn cow. And to engage the quill manually, you just do it just like you would a regular drill press. You go up and down. And you can just manually drill using that action right there. When you come down, you'll notice that you got the slot here. This has a Morse taper in here, so you can put different tooling. This particular one takes a number 5 Morse taper, and I've just got a drill chuck mounted on that. You can put big taper shank drill bits directly in here. You can put boring heads in here. Whatever kind of tooling you got to mount on a number 5 Morse taper, you can put right in here. All right, so tell you what, let's engage the spindle. And we got another real cool thing here with this as far as feed. It has power feed that will feed down. So we'll engage the spindle. And when you pull these handles out like this, you engage the automatic feed. And if you notice, this thing is actually going down on its own right now. There are 4 speeds to that feed. And this up here on this selector dial, you got 6, 15, 11, and 20. And what those numbers are is thousandths per revolution of the drill. So as that drill is turning, for every revolution right now, it's going down 11 thousandths of an inch. And again, 6, 15, 11, and 20 are my options there. If you speed it up, obviously it's going to go down faster because it's based on the RPMs that you're doing here as far as how fast it goes down. So to change your speeds, or your feed, excuse me, we'll let the spindle stop there. All I got to do is do that, and I'll go up my 20, engage it now, and you see it's going at a faster feed rate. You come back out, you can manually pull it back out. Now this lever here controls the actual speed of the spindle. Right now we're running at 145 RPMs, revolutions per minute, and we can change that. There's 2 handles here that control 2 different ranges. There's 3 options for each range. So this first one here, you got 145, 200, it's going to go over here to 100. So you got 3 spots there. Now the next one is you pull this handle down here. Now we're in 505, 715, and 350. Pull it again, we're in 990, 2000, and 1425. So let's go back. So 100 RPMs will be our slowest speed on here. I honestly kind of wish that it had something a little bit slower than that for doing really large work. We can go to 200. I'm not going to hit them all. There's 505 RPMs. Move them up to 1425. Humming pretty good now. And then the maximum feed rate there is 2,000 RPMs. Now when you engage the cow horns, see it's going down pretty fast. 20 thousandths per revolution. All right, let's drill a hole. So what I did is I got a vise bolted down to the table here. This is about a 1/2 inch piece of steel, and I put a center punch on there where I want to drill a hole. And just like we talked about before, we're just going to go right over there to it. First thing I'm going to do is I'm going to lower my head down a little bit closer where I don't have quite as much to work with there. I've got my head here disengaged where I can swing it around. We'll come out here and we'll just fine tune this thing until we get right over that center punch hole. All right, I'm on that hole and I'm locking my table down. So we've got a 7/16 inch drill bit. I've got a chart here that tells me spindle speeds for the size of the drill plus the material, and I look on here, 7/16 inch drill size. I'm gonna call this medium steel. It's calling for 693 RPMs would be the optimum speed. And of course, I'm not gonna have that exact speed on here, but the closest one I've got is 715, which is just a little bit faster. So I'm gonna engage that. We'll turn our spindle on, and for this one, we're just gonna do it by hand. So I'm just gonna come in here and manually drill the hole. Let's do it. All right, we are through. So I went over and found a drill bit here. This is number 5 Morse taper on this end. I could use another one with a reducing sleeve, but this drill bit looks like it's in pretty good shape. It happens to be 1 9/16. So we're going to try that one on here and just go straight to it. So first thing I need to do is go up with the head, so we got a little more room up underneath there. So let's raise this thing up. That ought to be good. I'm gonna come down till we got our knockout here, and I got a drift here to knock out my spindle that's in there. Let's put that in there, and we'll take a hammer here. Need a third hand. There we go. Let's see, raise this back up. All right, got that drill bit in there. Let me lower it back down a little bit closer. All right, so as far as my speed goes, 9/16 isn't on here, but it's going to be between 1/2 and 5/8. So that's calling between 188 and 204. So I tell you what we're going to do. We're going to go with 200 RPMs on our speed. All right, we're going to come down here. I've got my feed rate set on 11 thousandths per revolution. And we're just going to engage our cow horns and stand back and see what happens. Put a little oil in here. Let's try that again. I think that 11 would have been fine, but I want to be a little more conservative until we try this thing out. I don't think my grind on my drill bit's just exactly right, but it is making a nice chip. All right, we got a fully engaged cut now. It's doing much better. Much better sounding. All right. One nice hole. All right, so we end up with a pretty decent little hole here. I will just say that I think that my grind on that, although it looked like a good grind, it was cutting more on one side than the other. And it was making for a pretty rough cut until we got it down fully engaged in there. Once it got fully engaged on both sides or all the way around, it really did a lot better. But the first little bit of that was kind of rough. But all in all, it shows the machine's very capable. All right, guys, there you go. There's the Carlton drill press. Pretty excited to have this thing running. Still got just a couple of things I need to do. It's sitting up on blocks right now where I was moving it around with a pallet jack. I need to get it sitting on the floor, and I've actually got some concrete anchors ordered. I'm going to clamp or bolt this thing down to the floor. Because this arm swings out on either side, although it's designed so it shouldn't tip over, I'm still just a little bit worried about it. So I've heard horror stories of these things falling over in some shops, so we're going to bolt it down to the ground just to be on the safe side. So I've still got to kind of get it exactly where it's going to sit, get those in there. But other than that, she's ready to go. So let's go over to this Cincinnati Bickford, give you a quick overview of it, and then try some holes on it as well. So up next we have the Cincinnati Bickford 21-inch super service drill press. So this one's a little bit different than the Carlton. Similar capacity as far as, you know, the horsepower, the spindles, and so forth like that. This one does take a number 4 Morse taper rather than the number 5 over there, but works very similar. We've got a similar range of speeds and feeds. We got the little cow horn device I'll show you here in a minute for the feed on here. But unlike that one, of course, this is more like a regular drill press where you get your work positioned up underneath it to wherever the spindle's at. It doesn't move around. So as far as movement on this, we do have a couple of adjustments that can be made. First off, over here on the side, if you loosen up a couple of bolts, and there's a handle here, and you can adjust the actual spindle height up and down. And we got a pretty good range here that this can move up and down. Go ahead and just lock her back in right there. And we also have down here again a couple of bolts to tighten and loosen up the main table, and the table will raise and lower. And we showed a previous video where we did some work on that screw mechanism in there to raise and lower this. So you got two adjustments in height. Between the two, you lower that all the way down and raise this all the way up. You can get a pretty good size piece of material in here, or you can get them pretty close together for doing smaller stuff. So anyway, nice to have that range in height. Up here on the head, we have our speed selector here, and it goes from, it says, I think this is 10. It's hard, that first number is not real obvious on there, but it says 0, but I think that's 10 or maybe 20. I need to look that up. You can't really see it embossed in there, but that's going to be our slowest speed, and our high speed is about 1200 RPMs. And it's got 3 ranges that way, and then 3 ranges this way to get in there where you're at. So much slower RPM on the low end and not quite as fast on the high end. That's our 1200 RPM. We got our selector here. This is for forward is down, and then reverse is up. So we got that, and then over here we have the feed for going down. It's got basically it's in out now, but you got 4. This is again thousandths per revolution, 4 thousandths, 8 thousandths out. 14 and 20 thousandths. So a little bit different range in feeds, but similar again to the Carlton. And then over here on the side, again, we have our cow horns. And just like on the Carlton, this works just your quill up and down. And then to engage the feed, you pull them in. This one doesn't stay. It's spring-loaded. So I'm not sure if that's normal or abnormal, but you got to hold this one in to keep it engaged, whereas on the other one, you can let go of it. So anyway, let's put a drill in here, a piece of metal, and give this puppy a little challenge. All right, I got the same drill bit as we did before to start with. My speed is a little bit different just because of what's available in this. So we're doing this one at 532 RPMs. And we're just going to go ahead and do this first hole again by hand. All right, that drilled very similar to the other one. We were going a little bit higher speed on the other one, so I think this one's a little bit slower, but that's to be expected. I will say that just having used that one over there and using this one, I kind of like the quill handle here being on the side of the drill press rather than on the front of the drill press. That over there was a little bit unnatural to me just because of the way I'm used to using a drill press. In the long run, I don't think it's really going to matter. Just reposition your body and do it. But this did feel more natural just because this is how I'm used to using a drill press. Let's see what size drill bit we can find. I can't use that same one we just used because it was a number 5 Morse taper and it won't fit on here. I should have picked a number 4 where I could have used the same drill bit on both of them, but that's all right. I'm going to go find a similar size one. But it'll be a little bit different bit. We'll put it in here and give it a try. All right, so we've got a 1.5" drill bit in here. The grind on this one, quite honestly, doesn't look as good as the other one did, but that other one wasn't as good as I thought. So we'll see how this one goes. That was just the closest one I could find that would fit in this machine. Let's see, our speed, according to our chart, I think it was 204 RPMs is the optimum, and we're going to be going at 188. That's as close as I got. So that's our speed, and we're going to put this on. See, we were on 6 over there. I'm going to go with a 4,000 speed on there. We'll just go start conservative. So let's give her a try and see what she does. We'll come down by hand, and then I'll engage the cow horns here. little vibration going, but we're about to get the full cut. Yeah, we're making a full cut now. It's, again, looking a little bit better. I just did that to break that chip. So we're back re-engaged now. Just cutting on one side. Again, my drill bit's not the greatest in the world. I'm stopping my feed to break that chip, so it's going to take a little bit more to cut it. We're about to come out the bottom. And we are through. All right, we could have gone with a little bit faster feed on that, but again, a nice hole. Looks good. So, Cincinnati Bickford, thumbs up. It gets the approval here. I think it's ready to go. So I'm going to call both these machines in good shape and ready to go into regular practice. Again, on this machine, still just a couple little minor things that need to be done. On this one, I've still got a couple of tags I need to get restored and put back up on the motor and some other stuff. Nothing major. It's also sitting up on some blocks right now where I can move it around with a pallet jack. And I need to get this thing setting down on the floor. I'm probably not going to worry about bolting this one down. I don't think it's going to go anywhere. Although at some point in its life it did fall over. That was evident by some damage we saw when we were restoring this that had previously been repaired. And fortunately it looks like those repairs were good and it's not going to have any major impact on this machine. But thumbs up. I think it's ready to go. So guys, one thing I'm looking for this Carlton is there's a handle that's supposed to go in right here. I've just got a 1/2 inch bolt in here right now. It's 1/2 inch 13 threads, but this should have a handle, just like a handle like you'd have on a hand wheel, except a solid one, not one that rotates. And I can't find one. I can't find a source for one with that thread size. If anybody knows of where a handle like that might be, please let me know, because I would like to get this uncomfortable bolt out of here and a more appropriate handle. And let me show you what that handle should look like. So this is the handle up above it on the raising arm, or for raising and lowering the head, and you can see it's more like a handle off of a hand wheel. And I used to be able to get these from McMaster Car, but they're not carrying the solid ones. They still have the rotating one, revolving one, but again, I'm looking for a solid one. So if anybody knows a source for one of those, let me know. All right guys, I think that'll be a wrap on this video. So you see, we got 2 nice drill presses. We're ready to go into work here in the shop. Both these drill presses, because of the feed mechanism on them, can be used for not only for drilling, but you can use these for boring. You can put a boring head in here, just like you can on a milling machine, and bore with them. So I'm really excited to have this extra capacity in the shop, and I hope you are too. Thanks for watching.